You're listening to another episode of Recon Live. I'm Bruce Quick alongside Jason Whitmire, and we're super excited for today's podcast. But before we get started and introduce the topic, make sure you follow us on social media at Recon. You can find us on Facebook and Instagram, and then make sure you catch up on all the latest podcasts. We have over 10 episodes released, a full season 2 ahead of us, and we've even started working on season 3. So a lot more coming in the future. Make sure you turn on those post notifications so you know when every episode drops. More importantly, visit our website, rigrecon.com, for all the latest apparatus information. And when you're ready to build your next spec, this is the website that you're going to want to visit. Key product topics of things that go on fire trucks, everything from FAQ videos, technical videos, product comparisons, and comparison charts, and so much more. But nevertheless, before we get started today, Jason, we have the two guests from Waterous joining us, Jason and Todd here, and I don't want to take too much away from them. I'll let them introduce themselves. So, Jason, Todd, take it away.
Morning. My name's Todd Rogers. I am the customer service manager here at Waterous. Started back in the early to mid 80s with the Waterous company. A little bit about my background. I worked for a private fire apparatus repair facility prior to that for several years, servicing approximately 100 or so departments in the Minnesota and Wisconsin area. I also was a paid on-call firefighter, or more commonly known as volunteer, throughout a lot of the country. I did that for 29 years, so worked my way up through the ranks to the fire chief level. I served at that capacity for approximately 16 years. So the extension of that with the apparatus operator, both from hydrants and from drafting operations. And once I was hired on here at Waterous, I became basically a customer service rep. And then after several years of serving in that capacity, I moved out to the shop floor and oversaw the pump production area. So shipping, receiving, pump assembly, pump test, worked with the staff out there. And then just in the last several months, our service manager, Steve Moreland, retired after 40 some years. And I am now in the role of customer service manager. So thanks for having us.
Of course.
Hi, good morning. My name is Jason Araki, currently in the position of National Sales Manager here at Waterous. I have been here for 23 years, so not as long as Todd and actually a lot of my coworkers here at Waterous, but I actually started out in the shop following 4 years of active duty in the military. Started in the shop, actually assembling fire hydrants and valves, which is the other piece of our business here, core piece of our business here. 2007, when I graduated from college, I became an application specialist. We're basically a liaison between engineering and sales, and really built that foundation of the pump knowledge, which has been really great. So now serving as a national sales manager here, have an excellent team, sales managers that cover the entire U.S. and Canada. So it's a pleasure to be here. Thanks for having us today.
Awesome. Glad to have both of you here. I've had the opportunity to work with both of you. I can just say from in the industry, if you guys that are listening in need any help, these are two experts you can call on, and they are guys that will either answer the phone when you call or definitely return your phone call. So we're going to start off today, and we're going to talk about a subject that it's one from my history in the industry that sticks with me a little bit, and that's pump ratings. I think it's so misunderstood by people. Todd, you mentioned volunteer fire service. I'm in the volunteer fire service. I know in my area, sometimes someone buys a pump at a certain rating because they want to be bigger than the guy next door, which we all know we get a little competitive in the industry or in the market. And that's one part of it. But then I'll talk to someone seriously and say, well, no, why do you need a 2250 pump, for example, which is a pretty big pump for a commercial pumper? For industrial, that's common, but just for your normal municipal pumper, even 2000, it's become almost standard at times, but that's large. And then I ask, why do you need that? And they're like, well, we want to flow a whole bunch of lines. Okay, so you're worried about the 10-year fire. I get it. We all plan for the worst, but are you drafting at that fire? Well, no, we have hydrants everywhere. Well, that changes things. Now, I've talked about it in previous podcasts, but you guys are the experts. Talk to me, both of you, on your opinions on pump ratings, how you detect or how you actually rate the pump and the difference between drafting and a pressurized source.
Absolutely. So let's first start off with a Waterous full body, 1500 GPM single stage pump. I think that's a good place to start. That has a huge market presence. It's demanded by a lot of fire departments. It's called the Waterous CSU 1500. It's got a dual eye impeller, again, in the full body. Let's focus on starting the conversation off with per NFPA. Per NFPA, the pump manufacturer shall certify the fire pump is capable of pumping 100% of the rated capacity at 150 psi net pressure at the following: at an altitude of 2,000 feet above sea level, with a 10-foot lift, and with dual 6-inch suctions. But the Waterous CSU is capable of a whole lot more than that, guys. The pump is actually capable of achieving this performance with the single 6-inch suction. And some agencies out there actually meet this capacity or even higher, 1750 GPM performance with the Waterous pant leg suction, all off of one side of the truck. This is all in part because of the dual eye suction design of the Waterous CSU, as well as the efficiencies we've engineered into the pump. The CSU is available in ratings of 1500, 1750, 2000, and 2250, as you touched on, those larger capacities, Jason. Those are NFPA ratings, which is actually the same pump throughout. There's just a different impeller internally between the ratings of 1500 to 2000 range and the 2250 rating, or in certain circumstances, if there's an elevation issue where the larger impeller might need to be substituted, but that's not always the case. I'd also like to add that the Waterous CSU is actually capable of flowing the NFPA 1500 GPM with the single 6-inch suction with 10-foot lift and an elevation up to 10,300 feet. As for flowing from a positive inlet, as you touched on, Jason, a lot of these people are not drafting. So flowing from a positive inlet, not a draft. As you can see by the CSU curve that you guys are going to show in this feed here, the pump is actually capable of flowing in excess of 2,500 GPM. Todd, I'm not sure if you have anything to add to that.
Yeah. So if you look back, my days on the fire department serving as the fire chief, we served approximately 32 square miles of coverage area. Of that, about 65% of it was non-hydrant. So we tendered water, basically a lot of shuttles. We did have a couple dry hydrants, but seldom ever used them. One of the things that was important for us is to meet the ISO ratings. So for us to get the bigger capacity pumps, even though you'd never really pump at capacity on a fire incident, we looked at it for the ISO points. It was a cheap way to gain some points because you're adding an extra discharge valve and some plumbing, and basically you get to increase that capacity for the truck. So from a fire department standpoint, if you're into the ISO or your fire service rating is important, that is one way of achieving some of that. And that was our reasoning behind going to 200 or 1,250 gallons per minute or 2,250 gallon per minute pumps at our department.
And that is a great point. ISO, just for those that aren't aware, ISO lowers the insurance rating. If you get a great ISO rating, it's going to lower the insurance rating for everyone in your fire district. And that matters. I'll give you a great example. So my volunteer fire company has a Waterous CX pump. It's rated at 1500 GPM. We've pumped it. We've gone out from a pressurized source and done testing, and we've pumped it all the way up to about 2300. We probably could have got more out of it. Be totally honest, we ran out of people to hold hand lines, or we probably could have flowed more because there's plenty of inlet pressure coming in yet. But the point Todd makes there is, I could have, let's say I pushed 2,600 gallons per minute out of that truck. On paper, it does not matter. To ISO, that's a 1,500 gallon per minute rated pump.
Yep, and that's what they look at. So for us, just kind of example, it saved some of our taxpayers per residence anywhere from about $1,000 to $2,500 a year on insurance premiums in the rural areas.
Great.
So that the higher gallonage is really beneficial for that aspect.
Yeah, and in a recent podcast episode about pump controls, we talked about heat being the enemy of the pump. So maybe can you talk about the temperatures that can damage a pump, and then ultimately what that heat can do to the pump?
Certainly. So when we start looking at the Waterous pump, for example, if we go back to the CSU pump that Jason alluded to, if we were to remove the packing and the mechanical seal out of it, and we were to totally drain that pump, so there's absolutely no liquid in it, the Waterous pump could run for extended hours without overheating anything. So on the transmission end, we have bearings that are basically lubricated by ATF transmission fluid. On the outboard end, we have a sealed bearing out there. So that's supporting the shaft assembly. Internally, nothing's in contact. So the wear rings and impeller hubs have a couple thousandths, few thousandths clearance to them, and nothing is in contact. So that could run for extended periods, just like if you picked the front of a bicycle up and spun the front tire. What causes the heat is the same thing we use to cool the pump, and that is when we start adding water to it. So when we install our wear rings or our mechanical seals or packing in a pump, those are basically contact points. So mechanical seals are designed not to leak, so they'll seal up and they're in contact. So two silica carbide type rings, one stationary, one rotating, are touching each other at any given time. So we need water to cool them. When it comes to packing, they're in contact with the moving impeller shaft. So with that, we need water in there to cool the packing so we don't score the impeller shaft. So there we have a drip rate.
Todd,
So
real quick for our audience.
Yes.
Explain what packing is, what the material is.
So packing it's typically a graphite type material. They refer to it as a rope packing, so it's kind of woven together. There's other types that are basically chunks of this that are pressed together. And then what they do is they slide inside a cartridge basically between the impeller shaft and the pump body. And then what happens as you adjust packings, you're looking for a drip rate on a Waterous product between 10 and 120 drips per minute at 150 PSI. So there's two little nuts on there that you basically just adjust approximately one flat at a time, and it slowly compresses the packing, which brings it closer to the impeller shaft. So when that occurs, we get that drip rate down into that 10 to 120 drips per minute. That basically helps you, especially if you're a department that does a lot of drafting.
Is there a rough percentage that you could estimate pumps that have mechanical seals versus packing these days?
Pretty much all of our end suction pumps. So anything that has an open end intake where it's supported just from the transmission or pedestal, and what we call an end suction pump, the vast majority of those are all going to be mechanical seal. When you get into midship pumps, basically our CM or CS versions, CSU, CMU, those will typically probably in that 70 to 80% range are mechanical seal now.
I would agree with that.
So it's pretty close to that. So if we go back to this heating condition, if we add water into a pump and we're not moving it, that same water that we use to cool the pump is going to heat up and at some point convert basically to steam. So what ends up happening then is we start to overheat our mechanical seals and or packing to the point where, like a mechanical seal, once they're damaged, they have to be replaced, where the packing, on the other hand, is a little bit more forgiving. So it can be adjusted back in on the drip rate, but you also have to watch for damage to shafts and stuff. And that's the case with any centrifugal pump out there. So that's your two primary means of sealing the pumps up.
What's the recommended temperature that you don't go over?
Well, we have an overheat protection device that we install as an option. So basically, one of those, there's a couple different variations, but typically it's in that 120 to 140 degree temperature range. Okay. Once it exceeds that, we have a thermal valve that opens up and automatically starts dumping water to atmosphere. And then once that water internally on the pump has cooled enough to basically allow that thermal valve to reset, it'll reset itself until the next time the pump is potentially overheated. So that 120 to 140 range is a pretty safe number.
And I want to tag off of that. Mm-hmm. So if you look at a full body pump that Todd's talking about, typically you're going to have, 14 gallons of water?
Roughly 14.
Within the body?
Depends on the intake configuration and such.
So depending on your ambient temperature of the water that's coming into the pump, if you got your tank recirc line on, if it's a single stage or a two stage, is your tank made of poly or steel? That all kind of ends up in how fast you can get to an overheat condition. So you take an end suction pump, smaller volute, less water in there. Certainly something you have to be a little bit more cautious about. And here at Waterous, when we're out consulting with customers, we like to say we consult people and not sell people, so that they can make a good decision on behalf of their departments. We always say that it's good to get the cheap insurance, and the overheat protection manager would be a recommended cheap insurance policy for your fire pump.
Great point. I personally think it's something that should be standard in every truck, because like you said, it's not terribly expensive. And I know we're all self-conscious of the price of these trucks because they keep going up and up, but we're talking something here that is a fraction of a percentage of the cost of that truck.
Correct. And it's another way you can check that. I mean, if you just feel the discharges, so a good apparatus operator, when they're basically at the pump panel, if they're flowing off discharge, feel the intake, feel the discharges. If you're flowing from a particular line, seasoned firefighters will know water coming out of the nozzle, if it's warm or if the hose line is warm, that they need to get more water discharged out of the pump. Because if it's warm out that far, the end of 150, 200, 250 foot hose lay, I can tell you, rest assured that it's real warm or dang hot inside the pump.
Yeah, if you lean your hand on the discharge elbow and it kind of sticks to it and burns, that's not good.
Things are going to start welding itself together here real soon.
Yeah.
So start moving water.
Things will start arguing inside the pump real quick when they get warm out.
So you touched on heat and how the water coming in, as you start to just churn that water around, you're heating it up, and now you're turning to steam, which kind of ties us right into our next destructive force on that pump, and that's cavitation. And I think you touched on a little bit of this when you started out, because you were talking about running a pump dry, where you don't have any water in there whatsoever, versus running it in there with water that's heating up, or just a little bit of water. Do you want to expand on, I think cavitation is a very misunderstood thing in this industry.
There are, and any centrifugal pump can be cavitated. Typically what ends up happening is you have really two types of cavitation. So you have your traditional cavitation, most people understand, and that is a lack of water supply coming into the pump. So for example, if we're drafting, you don't have a suction hose that's fully sealed, or maybe it's got pinhole in it or bad gaskets. On the clear suction hose nowadays, you can actually see the water bubbles coming up into the intake. So you're pulling air in. So as that pump is operating, you're going to start to notice a couple things. If it's traditional cavitation, you will hear sounds. So it'll be kind of a marbly sound, like rocks going through the pump. It could be engine RPM fluctuations. So you'll start seeing the engine RPMs, are hearing them up and down a little bit. You'll notice discharge pressure fluctuation. So the discharge gauge, you may increase engine RPM, but then all of a sudden the discharge side does not have a corresponding response. So it starts to fall off. Or you'll notice kind of a basically a rough feeling hand line or nozzle discharge where the nozzle is jumping, pulsating. And you'll also feel some temperature change. So as that pump is running out of water, potentially heating up, those are all signs of what we call basically your intake or side cavitation. The other one that not many people know about is the recirculation type of cavitation. In that situation, you have plenty of water in the pump, but we're not getting enough discharged. So we kind of go back to that, say that 2,250 gallons per minute that we were alluding to earlier. If you have a pump that's rated for 2,250 and maybe it's a big end suction pump, for example, and you think you're going to basically have that, you're going to get all this water flow out of it, yet you seldom ever flow capacity out of the pump. Typically, it's only at the annual pump test.
Right.
So when you start flowing from a single discharge valve, for example, or two discharges on a fire incident, you'll get a different type of cavitation. And that's where you'll hear the marbly sound again, but you can feel those discharges either at the pump panel or through the hose line out the nozzle, or just feel some of the water being discharged where that water gets real hot. And that's a sign of recirculation cavitation. So we have plenty of water in the impeller coming out of the impeller, but there's really nowhere for it to go on the discharge side. And what you'll notice on some pumps is that if you're doing that extended periods of time, numerous occasions or occurrences, that it'll start to eat away at the vanes and shrouds on the impeller to the point where those vanes will break off. And someday you'll go and drain a hose line out and you'll find a chunk of brass that comes out the end and it's all jagged on the sides. That's all typically signs of recirculation cavitation.
I think the neat thing that was explained to me once was how you're spinning that impeller, you're heating that water up, you're changing pressures inside there, and those little water bubbles almost become missiles that are driving through that brass impeller at that point.
They do. So on the low pressure side, they're coming in and they break down. So really what it's doing is it's forming vapor pockets. As they travel through the intake of the impeller out through the discharge side, where they get back to high pressure, they implode. So basically when they do it with such destructive force that it'll start to eat away at the pump body, the stripping edge of the pump, and potentially the impeller. So those little implosions that are taking place is actually kind of that marbly sound. That's a byproduct of that.
Great explanation. Appreciate it.
Yeah, and as we wrap up sort of the dangers of a pump, and after this discussion, we'll sort of shift focus here. But one last thing, if you heat a pump up and then introduce cold water rapidly, can this damage things like the mechanical seal, for example?
Yes, if you get it hot enough, there's several things that can occur. If you go from a real hot pump internally to thermal shock with cold water, it can affect mechanical seals. Early models of mechanical seals used to be a steel or resist type stationary ring, kind of a stainless material. And then the rotating portion was some sort of a silicone device or basically component. And what ended up happening is the thermal shock, there was enough difference between those two components that it would actually fracture the mechanical seals. Nowadays, you don't see that so much because we use similar components at both locations, the stationary ring and the rotating bellows portion. So it's not as prevalent, but yes, you get it hot enough, you can affect that. Just like if you have poly discharge balls on your valves, they can be deformed. And then once, things cool down or you hit it with cold water, they used to lose their shape. And then all of a sudden now you have a discharge valve leaking. So there are things that can be affected by it with the thermal shock. Typically mechanical seals, they'll be succumb to that at times where packing, you get it that hot and it starts to wear on the impeller shaft, you'll get grooves in the impeller shaft. And the byproduct of that will be when you make packing adjustments, they'll hold for a short period of time. And then all of a sudden, a few, operations later, they're leaking bad again. So you have these peaks and valleys throughout the impeller shaft. And what ends up happening there is the shaft has to be replaced at some point to resolve the issue. You can try to repack those pumps and the new packing will be a little bit more pliable, but yes, once that shaft is damaged enough, it's not going to hold its adjustment like it typically would.
Jason, before we shift subjects here, we're gonna shift on to primers, but something just popped into my head on one more thing that is pretty inexpensive that can help prevent damage to the pump, and that's anodes. Do you want to talk a little bit about what anodes do?
Absolutely. So what year did we switch to magnesium? It's like
Just a couple years ago.
Yeah, like 2020. So you have a lot of dissimilar metals inside the pump. So you have the stainless steel impeller shaft assembly, you have the bronze or brass impellers, and then the cast iron pump. So you got water that's being charged. You got a lot of particles in there that can cause corrosion. So we put components within the pump. Again, cheap insurance like the OPM. Components in the pump that will self-destruct for the life of the pump. They sacrifice themselves. So it's what we call cathodic protection. So the zinc screens that we put exterior of the pump, they form a barrier within the intake fittings. Those are made out of zinc, and they, through the life of the pump, they will sacrifice themselves. And then more recently, we moved from zinc anodes to magnesium anodes within the last 5 or 6 years. And magnesium conducts a little bit better, and therefore it will sacrifice a little bit better on behalf of the fire pump. So, great way for cheap insurance. Not anything unlike at home. If you look at your water heater, you probably have some sacrificial anodes that are inside of your water heaters as well, because there's a lot of minerals in your water, and those will sacrifice and protect your water heater as well.
And one point to the end user here is they're great, they're inexpensive, they're a great way to protect things. Don't get upset when they start to get eaten away. That's their design. You need to check them every few years and replace them because they're supposed to get eaten away.
Yep. So if you look back in the day, I'm kind of dating myself here, but the old apparatus used to have steel water tanks, whether it be galvanneal, stainless, whatever. But most of those had some form of an anode in them. And anytime water is moving, it's just driving down the road with the water sloshing inside of the booster tank, you're going to create basically electrical charge. And basically with that water sloshing like that, the old days, all those anode rods that were in the booster tanks were there to minimize any basically electrolysis internally. So dissimilar metals were protected better. We started transitioning into the fiberglass and the poly tanks. The need for those anodes to protect the tank were gone. So all that surface area of zinc back then is now basically down to the intake screens and whatever little protection we put on auxiliary anodes. So that's something else that comes into play. Plus, water nowadays seems just to be a little bit more brackishy and corrosive than in some areas than it has historically throughout the U.S.
Yeah, it's really good to get into your spec to have at least an anode left and right on the intakes. Waterous manufacturers, when we make our intake fittings, there's a lot of open ports that are options for the OEM engineering staff, and typically not all those ports are being used for like elbows or outlets or anything like that. So typically you'd put like a blind flange on there. In this case, it'd be good to throw in an anode, slight upcharge, but it's that cheap insurance that's going to protect the life of that pump.
It's also something really simple to add on. So if you're listening to this podcast and you're like, well, we just got a truck, we're not speccing a new one, look and see if your truck has them now, because it's not a difficult add-on.
Nope. The more you can increase the surface area. So any blind flanges, so a blind flange, anything where it's just a 4-bolt pad or 8-bolt pad that's bolted to the pump, discharge fittings or intake that are not being used, they're perfect candidates to add additional anodes into, just to try to increase that surface area of protection internally in the pump.
So we're going to shift gears here to another product that Waterous makes. It's another product that's critical to the pump. We've talked about operating from a pressurized source. We've also talked about operating from draft. And when we operate from draft, we have to prime that pump to get water into the pump. For years, we had one option. That was an electric primer. The air primer came onto the scene. It's probably longer than I'm thinking, but it's at least 10 to 15 years ago, but it's dominating the industry now, I would say. You guys offer both. Can you talk to us about the difference and the benefits and drawbacks of air versus electric primers?
Certainly. So when you start looking at priming type devices, historically, as you mentioned, it's been electric. Electric primers have served well for years in the fire service. One of the drawbacks to electric primers is the amperage draw. So you always had to basically factor that in. Large cables from the battery down to the priming pump, larger alternators, charging systems. So back then, the early models, you didn't have the LED lighting like you do today. So you had conventional bulbs, filament type bulbs and such. So everything was drawing a lot more amperage.
That's how you knew it was working, Todd, when you pulled it and everything dimmed.
When the lights dimmed.
Yeah. When the primer was stuck up, rotating lights usually down and got dim. So.
Yeah.
But anyway, so basically they've worked well. In a way, a centrifugal little basically rotary pump works for the priming system is you have 3 or 4 vanes typically on a Waterous. So if it's our older VPE, which is electric with an oil primer, those had 3 vanes in them. And basically it just rotates and then it's basically eccentrically mounted. So it would draft or pull a prime. The oil was in there to lube those vanes so they didn't wear out. Then we transitioned into what we call a VPO, which is an oilless primer. So basically that went to 4 vanes with a little bit of smaller rotor. And we use basically materials internally, coatings, to basically lubricate those vanes. So we didn't need the oil in them. For those that like using the primer oil and do a lot of drafting, and they use it maybe not so much from municipal system for a tender shuttle, but maybe they're pulling from a lake, pond, or stream, or they have more of a contaminated water, with sediment and such, then typically adding that oil option into it and just basically using like prime safe uh, biodegradable oil that you can run in and keep those moved also helps prolong the life. When you start comparing that to a pneumatic or an air primer, the differences are obviously the voltage drop is not a concern anymore, or the voltage amperage draw. So that goes away. Then you start relying basically on the apparatus air system. So basically making sure that you have the right size air lines feeding the air primer, servicing the air primer. So if it has a Y strainer in line, for example, and we go back to this water supply that maybe has sediment and such, it's imperative that typically after you use these, or monthly, whatever your protocol is for your department, you should periodically check those strainers that are in line just to make sure that they don't have any impurities in them. Basically, air dryers come into play then, especially cold water environments like we have here in Minnesota, making sure that it's got an air dryer on the apparatus and that it is being serviced and it's functional, so we don't get moisture into the air primer circuits. And that's for anybody's air primer that's out there. It doesn't matter a brand. Water, basically an airline, is never a good thing.
Right.
I think the popularity of the air primer has grown just because of easy use. So you have that auto prime function on the Waterous Venturis air primer. We have that auto prime feature, but we've also introduced that auto prime feature available on our rotary vane electric priming system as well. And if you go to waterousco.com under Waterous University, there's a lot of talking points that we've put out there for the benefit of committees that are making decisions on behalf of their fire departments. We try to put out unbiased white papers. For this example, we try to put out an unbiased white paper about why you would maybe pick an electric primer over an air primer. And there's some good notes in there. One that I'll just call out is like if you have a long run for a front suction or a rear suction and really need that deep prime, sometimes maybe the electric primer might be your product of choice for that. Both their options are available with multiple vacuum actuated priming connections to be able to have multiple priming capacity as well.
The other place that I've seen it sometimes is if you have an extreme lift. You mentioned NFPA testing earlier, and you mentioned that we need to test everything at 10 foot of lift. If you've got an area in your fire district where you're going off the side of a bridge and you've got 20 feet of lift, you want to be careful and talk to people and make sure that that air primer is going to work, because you may need an electric there or some type of an assist device.
Correct. Yeah, it's a very valid point. You get into heavy drafting operations where you do a lot of drafting. You have variables of lift, as you mentioned. A lot of cases, electric primer is probably the way to go for those departments. If you're in a municipal department or you're doing very little drafting, or maybe like tender shuttles, things like that, you can get by with air or electric primer. It's really up to your choice. Obviously, electric primers, when they're operating, are noisier than an air, just because of the rotors and the operation. But overall, they both perform well. It's just, you really got to watch your application and, look at that when you factor in your apparatus.
And on the topic of air versus the electric primer, can you guys talk about maybe the maintenance difference between the two?
So maintenance wise, if you do your monthly, weekly, whatever your truck checks are, some departments will run their primer every time. Others will just do the annual maintenance, which is the basically annual pump test. When you pull down a dry vacuum test is typically the best way to look. So drain the pump, close all your your discharges, stuff like that, and just pull down and see if you can pull that approximately 22 inches of vacuum and basically time it. So typically at 1250 or less, I think it's 30 seconds. If it's a 1500 gallon per minute, you get another 15. If you're pulling from a front or rear suction, you get another 15 seconds. So you have anywhere from 30 seconds up to 1 minute to pull the prime, depending on what you're pulling with. If it's struggling to get to 22 inches of vacuum on a rotary, or not a rotary, but basically our primers, typically it's time to re-kit it. So we have a kit that you can go in, dismantle the primer, replace the vanes. There's some shims and such to put in, and then reassemble it. And typically that primer is good to go for extended periods again. On the pneumatic primer, the air primer, a little bit less maintenance stuff, but you still want to check your push to connect or compression fittings that they're using for the air circuit, making sure that those are tight, not leaking. Again, do the 22-inch pull down, make sure that it's within reason on the time. If it exceeds that, then maybe apply strainer, look for moisture in the air lines, things like that. Some of them you can re-kit, some you can't, depends on the brand, but just keep that in mind. Once you repair them, typically they should restore back to meet the NFPA requirement for pull down time.
One last thing I'll say on primers, just in general, we gave some great examples of reasons to consider electric versus air. If you're in a department now that's using an electric and you've had some problems with it, I can tell you from personal experience, the retrofit from electric to air is not that difficult to do. I mean, the shop can do it in a heartbeat, but we actually did it at our firehouse and none of us are mechanics. So it's really not that difficult to do if you're looking to consider that. One of the things
it's not terrible to do.
One of the things that we pride ourselves on here at Rig Recon, and Bruce touched on this at the beginning, is we really like getting how-to videos out there. We know that people don't read books and manuals anymore. So animations that show things, how-to videos, guides, I think they're great. And that's somewhere that we line up great with Waterous as a partner and a friend here. I can tell you that I've taught some pump classes, and years ago, it was a little thumb drive that you gave out that had that exploded animation where you could take an operating pump and blow it apart and still watch it spin and see how it worked. I wanted you guys to talk a little bit about Waterous University and some of the really cool tools you have. And we're gonna show some of them in this video as well.
Fantastic. Teaching and providing free educational items to our customers is absolutely a passion of ours. A lot of people here within our organization are actual firefighters as well, so they've been behind the creation of a lot of our expansive library, again, that we have the free educational pieces. It's all at waterousco.com under Waterous University. If you need any help finding it, feel free to reach out. Jason, you guys can go ahead and drop our contact information in there. But we've invested in developing free 3D animations for the public to use in educational purposes. And it's really been fantastic. The 3D animations in videos help pump operators understand how the centrifugal fire pump works behind that bright, shiny panel. Out of the development of these 3D animations come the benefits of being able to show the serviceability of our products on a Waterous 3D in the animation as well. It's been a great investment for our company, which has had a powerful impact for our customers. We'd invite customers to go ahead and reach out, and I can go ahead and provide a demonstration as well. So as Jason said, we do have the 3D flash drives available, or you can just drop onto our website, log in a couple credentials, and put a request in it, and you can go ahead and load it up onto your computer. But out of this, it's just it's been amazing to be able to create the library of literature and data to be able to help our customers understand what's going on behind that bright, shiny panel. I think a picture is worth 1,000 words.
Oh, yeah.
And we're still not done creating the educational topics out of this. And I might add, if somebody out there would like to see a, Waterous training on a certain aspect that's currently not on Waterous University, feel free to reach out and we can engage and create some educational pieces on that.
Yeah. So we also have mywaterous.com. If you're looking for specifics to a given Waterous pump, and it's say within 2000 and newer, typically, if you go on there and log into mywaterous.com, go on there, enter as a guest. So we don't need all your credentials, anything like that. You won't get any junk mail from us. Turn around, and then on the left side of that, enter serial number for that particular pump, and it'll basically populate for you. And as you scroll down there, it'll tell you everything about that pump, what was sold with it. And off to the right of it is the different drawings and stuff like that. So if you're not sure what you have on a pump, log Waterous' serial number in, and then you can actually pull the drawings from that document also, or from that website, and then use those to go back to the Waterous University and look for the different videos related to it.
I also want to take off of the Waterous University, the type of products or the videos that we're putting out there. Some of them are a little bit longer, but it's all designed around being educational. And again, taking that consultative approach in arming committees out there so that they can make the best decision on behalf of their fire departments. We put a lot of videos out there, what we call shorts. We understand a lot of people, including myself, I got a short attention span, but you get into the shorts videos where you're less than 60 seconds, and we're just trying to educate, maybe perhaps on why we do flame-plated impeller hubs on our products. We get into discharge valves. We talk about priming systems and things like that. So these are easy and fun ways for apparatus committees to engage on those topics and learn a little bit and see through the video. And we do enter a lot of the 3D animations as we roll through these videos as well. So again, if anybody out there wants to see other topics where we would engage on an educational piece, whether it be a video, a short video, or a white paper, please reach out, and we'd love to do that for you.
Yeah, our shorts, we like to throw a little humor in them, and then when we're done, we razz each other how bad we were on there. So
is the humor you just throw Greg's picture up and then
yeah.
Todd actually just recently did a really fun one for refurbs. We hear out there that with apparatus lead times and such, there's some people that are looking at doing a pump refurbs and things like that.
Yeah.
So Todd did I won't spoil the surprise, but if you haven't seen it, check it out on Waterous University on refurbs. It's a pretty good video.
I had trouble getting my big belly underneath the truck, but we did.
No, that's all really great stuff, and I think it's important that you guys are educating the customer, consulting the customer, right? I think having that all there is super valuable. Jason, from a sales standpoint, what are the top 3 things to consider when you're ready to purchase a pump?
One of the things that immediately comes to mind is our customer service support throughout the life of the pump. So even after we sell that pump, it's not like you're going to see taillights and we're gone, right? We're here to support that pump, and sometimes we joke about that here internally because we have records that go all the way back to the 1800s on our product line. So, but we invest in the personnel to be able to support your personnel out in the field. So at any given moment, we have 10 customer service staff on staff at any given time because we want to be easy to do business with, which means easy to contact and easy to do business with within our support structure because our customers really deserve that. Over 95% of our parts orders received ship within 2 business days, ground shipments, that is. And on some of those parts orders, they ship same day if they're rush orders. We have over 900,000 parts in inventory. Those are parts that are actually dedicated to aftermarket. We maintain an order accuracy of 99% for all of our parts orders. Waterous also has that portal that Todd was talking about earlier of My Waterous as well. So we want to continue to be easy to do business with. Secondly, I would say one of the more important things to consider when purchasing a pump is to get educated on the different styles of pumps out there. So we pride ourselves on being the subject matter experts on fire pumps, and we always welcome people to call us. There's no such thing as a bad question ever. So please reach out. Not all pumps are created equal. For example, there are end suction pumps, single eye impeller pumps, and full body pumps, which are actually dual eye impeller pumps, typically used on pumpers. We are the gold standard for the big cities all across the nation, across North America. It's important to understand the performance capabilities of each style of pump to ensure that you and your committees are making good choice for your department. Additionally, I would like to add, you need a single stage pump, two-stage pump, split shaft pump, PTO pump, etc. There's a lot of different holes that you can go down when you're talking pumps. So we would really like to be able to be here and offer up that consultative support to be able to educate apparatus committees so that they can make a good, solid decision on behalf of their department. And then thirdly, I'd like to say the third important factor is to consider when choosing a pump is look at the company's footprint in the industry. Waterous is currently demanded in 8 out of the 10 largest cities across the U.S. and most of the largest agencies up in Canada as well. And we have a time-tested, battle-proven track record. This is not a responsibility that we take lightly. As I stated, a lot of us are firefighters. We're fully immersed into fire suppression. Waterous our focus is solely on fire pumps, fire hydrants, and valves. And we hyper-focus on these specific products because we know it's important at the end of the day for our customers that we have their backs. So it's a mutual trust that we invest our entire existence to as a company. We're also authentically made in the USA. And what I mean by that is that our products are cast, engineered, machined, assembled, and tested in the United States. Waterous engineers design products. We think about the maintenance personnel that are eventually going to service it. That goes heavily into the development of our new products to make sure that when eventually the time does come that they got to maintenance those, that we've thought of them and make it easier on their lives. All in all, I would just say that you look at the commitment and the footprint in the industry, and fire suppression is something that is very near and dear to our hearts here at Waterous.
Excellent.
Yeah, and then wrapping up here, Todd, what are your top 3 things to consider to extend the life of the pump once it's in service, whether it's maintenance or operations, etc.?
Basically is to make sure that you're running these pumps. The worst thing for a fire apparatus to do is just sit. So if you're not exercising the valves, the priming system, running the relief valve systems or pressure management system on them on a regular basis, things start to dry up. So O-rings, things like that. The face of the balls on the seats, basically for your discharge and suction valves, they start to dry out. So they'll score as you open and close them. So we do have on by Waterous and then also on Waterous University a checklist that you can do weekly, monthly, annual type operations for your pump to prolong the life of them. Another thing is just a good maintenance program, documenting stuff. And again, that kind of goes back to the ISO discussion we had early on. They want records. They want to know, what do you do weekly, monthly, annually for service on these apparatus to make sure that they're maintained in a ready condition. So the biggest thing is just operating them and making sure that everything is being flexed, basically open and closing discharge valves, things like that.
Awesome.
Yeah, that's all great stuff. And as we sort of end every episode, we usually open up the floor for sort of a review, final comments. I think we talked about a lot of great things today. We got all the way down in the weeds about pumps, but then we also talked about, and I think it's evidently clear through your guys' passion about the commitment to quality that Waterous exemplifies in the fire service, and how, like you talked about, a lot of the people on your team are firefighters or were firefighters and actually care about what they're doing, which can sometimes be hard to find with companies in this industry. So Jason, Todd, and Jason, I'll open it up to you guys for any final comments as we sort of wrap up today's episode.
I guess I would like to start off just by saying thank you for considering us for this. I've never done any podcasts like this or anything. So my grandkids are probably going to laugh at me about it because you've seen me on here. But the bottom line is, as Jason alluded to, we're very passionate about what we do here. So if we get a customer that calls in, they're dissatisfied with a product or something, first off, we're going to do what it takes to make it right and get them up and operational. And secondly is, we don't hesitate to get a hold of our engineering department or sales staff, whoever it is, just to say, hey, here's the problem we had. This could be a reoccurring thing in the future for other departments. So we address those. And I think we take a lot of pride in knowing that. And I'll tell you, when we go to trade shows and customer visits, different OEMs and stuff, that's one of the things we always hear positive about, is we're not afraid to react and correct things and improve our products. So we take a lot of pride in that. And again, I greatly appreciate you guys having us on the podcast here.
I second that. Thank you very much for having us. My wife would probably say I'm always the emotional one in the family, but it's the fire pump is the heart of the apparatus. It's what's saving life and property out there. It's what our men and women are going in to battle these flames with, and it's a responsibility on our hearts that we don't take lightly whatsoever. And we understand that if that product doesn't perform, that people are going to get hurt, and it'll end up in a bad day. So it's something that we definitely don't take lightly, and we just want to thank the public for your trust in us when you do choose Waterous.
I can echo that. I mean, I've got a background in the apparatus industry, and I know both of you sitting here feel the same way. If you know your products in a big city, which you mentioned you're in a lot of big cities, and you hear about something like a line of duty death, the first thing you look and see is what happened. Oh, they didn't have water to the line. Oh my. Like, please tell me it wasn't a fault in our product that may have cost someone their life. So we all care, we all pay attention. Biggest thing I'll say at the end here is educate. Just educate yourself. Recon, Waterous University, they're not, of course we're in business. Of course we want to sell our product, but the purpose of these sites aren't just to sales pitch you. They're to give you an education and let you make an educated decision on which product you want to buy going forward. One takeaway from the pump stuff, you got options. You got options in sizes. You got options in styles. If you have packing, it's going to drip. It's supposed to drip. If you have a mechanical seal, yes, it shouldn't drip. That's where I'll leave you for this episode.
And the apparatus committees out there, we have sales managers that are covering all the territory here in North America and globally. We would love to hear from you and be able to come out and sit down, have a cup of coffee, or have a Coke, and just talk through some of the questions that you have. And we just want to be able to help out. And thank you for your service, men and women that are out there on a daily basis. Much appreciated.
Yeah, thank you very much.
Yeah, so another great episode today. Again, thank you for you guys' time. You can tell the wealth of knowledge between you two. So this wraps up another episode of Rig Recon Live. Again, if you haven't already, follow us on social media at Rig Recon. You can find us on Facebook and Instagram. Catch up on all the latest episodes of Rig Recon Live. You can find it all on rigrecon.com or wherever you get your podcasts. And then most importantly, you got to visit rigrecon.com for all the latest apparatus content, educational tools, and all sorts of different features. So this has been another episode of Rig Recon Live, and until then, expect the best.